All right, so on this lovely day, we're going to be dividing complex numbers. One of the key skills that we need is to be able to multiply conjugates. Conjugates, again, are always exactly the same thing. They're binomials, except that one is plus, one is minus. So the pattern always is you take your first term and you square it. You take your second term and you square it, and you always put a minus in between. Now, some of you may notice there's actually a shorter cut when you're dealing with complex numbers. So this, of course, is 4, and this, of course, is plus 1, and my answer here is 5. So it turns out that whenever we're doing the conjugates with complex numbers, it actually always will become a plus here because the I squared will counter that negative. And we can effectively ignore the I and pay attention only to the coefficient. So this one here, super quick, 16. Ignore the I, put a plus, and square that, 4. When in doubt, just write the whole thing out. But if you remember shortcuts, holy glockenspiel, life just becomes so much better like that.
So you can just ignore the I.
Only for complex conjugates, yes. 36, always put a plus here, ignore the I, and square that. Boom. And here we get a 61. So this brings us to our super secret rule. So today, when we are dividing complex numbers, there cannot be complex numbers in the denominator. Just like we don't put decimals, fractions, or radicals in the denominator, we're not going to have I downstairs either. So we need to get rid of the I downstairs. So in order to simplify, we have to multiply the denominator by its, not reciprocal, but notice here, what happens up here? What happens to all the i's when you multiply these?
They square.
Are there any more i's? No more i's. So if you always multiply conjugates, then your I is poof. So we always multiply by conjugates relative to the denominator. Oops, learn to spell. And fix that. Multiply by its conjugate. This process has a great name. It is called rationalize the denominator. Rationalize the denominator. I am the denominator. I'll be back. So let's take a gander here. I'll look through 2 examples, and then it's your turn. So we're going to perform the given operation. Again, we're going to leave all answers in standard form, a plus bi. Even if there are fractions, the answer could look something like this. Notice it should be left like this, as opposed to leaving it like this. 1 plus 3i over 2. So this bottom one would not be standard form, but this would be, because you have your real part and your complex part here. All right, so taking a gander here. The way that we attack this is always look here, and we need to rationalize it by multiplying by its conjugate. Always. And remember, math is always done in pairs. In order to balance this out, we have to multiply somewhere else. In this case, I'm going to multiply upstairs in the numerator. So let's go ahead and simplify. Don't forget that putting parentheses there in the numerator and denominator will help, especially when you're doing your double distribution. Okay, continuing on here. Downstairs, if you remember the shortcut, 1 plus 1. The numerator, I get a 6. I get a 6i. Then I get a negative 4i, and that's a minus, and a negative 4i squared. Extend your vinculum so it covers the whole thing. And now I can simplify right here. The I squared will make the 4 positive. And I can start combining like terms. In the numerator, I get 10 from the 6 here and the 4 there. And then this here is 2i. And in the denominator is 2.
Why is it positive?
Now simplifying here, we see that as long as I can divide both the terms by 2, then it works out. And so my final answer is this, 5 plus I. And there we go. And now let's take a gander at B here. First thing to notice is that we need to multiply by the conjugate. So the conjugate would be 2 plus I. Don't forget your parentheses. And whatever I multiply in the denominator, I need to multiply in the numerator and put parentheses there. Down below, the denominator will always be 2, to undo that, it's 2 squared, so that becomes a 4, always becomes a plus, and only look at the coefficient here. Only look at the coefficient, the 1. So that means we're going to 1 square, so we get a 1 there. In the numerator, I'm going to get 6 plus 3i plus 4i plus 2i squared. Bring the vinculum all over. These two become 7i. The I squared here changes this to a negative, and now I can simplify everything. Here I have 6 minus 2, so that'll give me a 4. Then I have these two become 7i, and the denominator is 5. We're not done because I need to put this in standard form, so I split the fraction and leave the I on the outside. And this will be my answer.